Hey, welcome back to the channel. If you haven't done so, why don't you hit that little subscribe button for us? It really does help us out. Today's video is our first viewer suggested video. We're going to look at some basic soldering techniques and the equipment and consumables used in doing it. The subject of soldering can actually be quite in depth, and there's a lot more to it than we're going to cover. But we're going to look at the basics needed to do through-hole and some surface mount soldering. So, if you stick around, we'll show you how to get it done. Hey, welcome back. Today on the bench we have, well, nothing. But there's a reason for that. Today's video is actually a request of you guys, the viewers. I've had several requests on doing a basic soldering technique video. So that's what we're going to work on today. We're going to look at a few different things. We're going to look at the equipment, the supplies needed, and some of the basic technique. Now, soldering is not horribly hard to do, especially on the bigger type components, through-hole type components, the old school stuff. But it definitely takes some practice, just like any other skill. And it can be learned relatively quick. Although, and here goes the public announcement warning label, please do not attempt your first soldering jobs on surface mount microscopic parts or on boards that you care deeply about. So if you're trying to resurrect that Channel F console or a Bally's Astrocade and you've got no soldering skills, it's probably not the best thing to work on. Now, on the other hand, if you're trying to restore an Atari 2600, they're a dime a dozen. Go for it. But there's some other methods we could use. Personally, you want to get some good practice? Go to Goodwill, go to your local thrift store, buy an old DVD player, buy an old VCR, anything like that. It's going to be cheap and you're not doing anything other than looking to destroy the item as you learn how to solder. So, with that in mind, let's go ahead and move forward. All right, the first point we're going to look at is the basic equipment for soldering. For most of us, that's going to be an inexpensive pencil, something like this. This particular one is probably only $15 to $20. And mind you, most of the products you're going to see today, they're going to be linked below. But you don't need a big, heavy iron, and certainly stay away from the big gun style with the wire bail. Those were really meant for heavy board or chassis soldering, back in the day. They've got no business being produced anymore. And I know I'm going to get some hate letters for that one, but there's some truth to it. For most repairs you're going to do on game consoles or cartridges, a small pencil like this is absolutely fine. Something in the 40 to 60 watt range would be great. The higher the wattage, the faster the recovery at the tip. And we'll get to that in just a moment. Also, if you can find one that has a temperature control, that does help in some cases. But a lot of the inexpensive ones from main brands like Weller or Hakko, they're going to be a little bit more thermally controlled even if you can't set the temperature. But there's no reason to break the bank on an iron either if you know you're just doing basic soldering. As you've seen in the past, and I've got another video on looking at my Hakko, and I'll link that above. An iron like this is completely temperature controlled, and it's a little on the pricey side for a hobbyist, but if you can afford something like this, it does make life easier. The next thing I'd like to talk about are our tips. The part that's actually going to do our soldering. A lot of basic soldering irons, the tip is either going to be clamped in, or like this one, there's a sleeve that comes off and we can change our tips. And as you can see, this one has the ceramic heater right here, and it goes up inside, which keeps the tip pretty close to our target temperature. The Hakko system, or some of the more expensive ones, the heater's actually built into the tip, and there's a thermal probe, a thermocouple, and it's mounted completely behind, or right behind, the actual soldering tip. That's why some of the more expensive ones are a little easier to work with. Thermal recovery is a lot faster. And what I mean by thermal recovery is, our tip might be sitting at, let's say, 380 degrees Celsius or 400 degrees Celsius. But when you, I know this is plastic, but for sake of demonstration, if you come down to a small point and touch that tip, if this entire spool was made out of copper, it would pull the heat away, forcing this to ramp up the current to try to bring the heat back into check. So what you'll find is, if you're soldering something like a battery that has a lot of mass, the iron may be hot enough to melt the solder and flow the solder, but as soon as you come down and you try to apply your solder, it freezes. Irons like this, or tips like this, for the Hakko, when you come down, it can sense the tip cooling quicker and it can recover quicker. So, on that note, proper tips are needed for different jobs. As you can see, many of my Hakko tips are very fine. This is a small conical. This is a small hooked, which gets us down into tight spots between chips for surface mount. And this is actually a very small chisel. It's hard to tell because there's still some residual solder on it. But chisel tips are kind of the workhorse whenever you start soldering. The one I generally keep on this, as you can see, is a 1.6 millimeter chisel. And this works fine for through hole and some surface mount. The reason you may want smaller or larger tips are, like in this case, to be able to fit into a smaller area. But when you have a larger tip with more mass, then your heat transfer is quicker and your recovery isn't as critical because you have more mass in the tip. So when you come to a part with more mass, the heat is available. The next part of this equation is the media we're going to use to do our soldering, which is our solder. So for a long time, the industry standard was a 60-40 lead tin alloy with a rosin core. This has been around for a very long time. More recently, they're trying to remove lead from circuit boards. So mass-produced circuit boards are going to have a lead-free solder. And if you're just getting into it, you might be inclined to buy a lead-free solder, but on a hobbyist level, stay away from it. It's harder to work with, it takes more heat to get it to flow, and there's more chances of a cold solder joint. So, even here at this bench, everything I use is leaded. The other thing is, stay away from some of the inexpensive Chinese solders. Now, I have gotten some decent solders from other parts of the world. This particular one came with a small kit, and I've tried to use it a few times, and it's garbage. So don't use it. Okay, so if you stick with name brands, I really like Kester solders. Most of them are made in the United States, and even the ones that are made outside of the United States are held to very high standards. Now, I'll buy a pound at a time. You don't need to buy this big of a roll. I've quite literally been using this roll of 60/40 probably for 4 years, maybe even longer, 5 years. And it's an extremely old roll. And, you know, if it doesn't get wet, this stuff more or less keeps forever. I know there's going to be people that will disagree with that, but from my own personal experience, I got several rolls out of my grandfather's TV shop that closed down in the late 90s, and this happens to be one of them, and it works absolutely fine. But as you can see, it's not gray, it's still pretty bright, and it's always kept in a temperature controlled area. Also, you know, something like these, you know, Radio Shack has been out of business, but there's a company that has come back and bought a few of their items and is selling them. And you can buy these spools at a much smaller weight. As you can see here, this is a 60/40. And these have become a little more economical than these. A spool like this is probably close to $30. A spool like this is probably only about $9. So, the next part of it is the actual alloy. Like I said, the 60/40 has been around forever. It was our standard. But there's been a push lately to go to a 6337 alloy, as you can see here. And this alloy is a little better balanced. It's known as a eutectic alloy. So this will melt at a lower temperature than either one of the two metals that are in it combined. And it has a very sharp melting point. It's right about 183 Celsius. And what it means is that it will go from a solid to a liquid and back to a solid in a very, very, very small window. So when you're soldering two items and you're flowing that solder in, as soon as you pull that heat away, it will go from a liquid to a solid, almost instantaneous. Which is important because if you got a piece of wire and you're trying to hold it, you know, as it's cooling, if you're moving it around as those crystals are trying to reform, you could break the crystals, which leads to a cold solder joint and a weak solder joint. 60/40 melts a little closer to 190 Celsius, and the window of melt to re-solidify is a little bigger. It works fine. If this is what you have, use it. If you're buying new solder, I would probably lean toward the 6337. The next consumable we're going to talk about is our flux or our rosin. As you can see here, these all say rosin core solder, rosin core solder, rosin core solder. Rosin is actually a natural product. It's kind of a dark yellow. And what the rosin or flux does in our soldering is first of all, it cleans the surface and the materials that we're soldering. So it's going to remove slight oxidation and any impurities to help keep everything flowing. The second thing is it's going to keep oxygen from entering and oxidizing things and causing cold solder joints. The third thing it does is adds to wetting. And if you've watched any of my other videos, especially when I'm trying to put a small chip on a, surface mount chip on a circuit board, you'll actually see that solder get bright and stand up like a drop of water. And when you put the chip on, it helps everything flow back together. And it really is, and I've said it on a lot of my videos, flux is our friend, and it's cheap insurance because it really, really helps the solder joints stay solid and clean and work the way they should. Now, these solders all have a rosin built into them. The wire is actually slightly hollow, and they put the rosin in it. There's also, you see me use this guy here, my syringe full of Amtech, and this is in case I need to add more rosin to the area I'm working. Like I said, cheap insurance, and it helps everything flow. The other style that you don't see very often, but I use it in the shop, is a small tin of paste rosin. And it's helpful if you're soldering wires, because you can just dip the end in. And we'll demonstrate that in a little while. Our final consumable in this is desoldering braid. Now, obviously you don't need it for soldering, but it's something that you're going to be using around the shop. It comes in a few varieties. One is a braid that is already impregnated with flux. And as I said before, flux helps the solder stay wetted and flow. So obviously when we're using desoldering braid, we want the solder to flow from our board and into this braid so we can get the part off. So you have with flux and without flux. And I don't use this style without flux very often, but sometimes if the board's already wet with flux, this is a slightly cheaper alternative, and I'll pick it up and use it. Now, if we take a peek under the microscope, you can see that this is made up of a lot of small, thin wires. And that's going to use, capillary action, just like if you were putting a paper towel down on a spill on your counter. The solder, when heated, becomes liquid, and it will pull it up. And here's what the one with flux looks like. As you can see, this one has much smaller wires, a much tighter weave. This is a better quality, but there's absolutely nothing wrong with some of these. This is inexpensive. You can get a few rolls of this for maybe $6 or $8. A larger spool like this is probably closer to the $20 mark. Copper has gotten expensive. All right, before you go attacking a circuit board with your iron and solder and newly found skills, you should definitely practice on some wire. Or, like I said, an inexpensive dead board. So, the concept of soldering is you're going to heat, you're going to heat the item or the object that you're going to solder, and you want the solder to flow to it. Now, there are some cases when you're doing surface mount where you will put the solder directly to the tip, because you're working with such small parts that the heat transfer is almost instantaneous. But when dealing with something larger like this wire, because we got it under here under the microscope, we're going to heat it up and we're going to add our solder. Now, to get things moving, you always want to put a little solder on the tip, just so it's ready to go. You're going to bring the solder to the wire. And you can see, you can just feed it right in. And you can see the rosin bubbling away. And there we go. We have a tinned wire. It will flow into the wire and leaving it looking like wire. The other thing is too, as you solder, you can see our tip here has gotten dirty. There's a couple different ways of cleaning. I used to use a wet sponge to dab, but anymore I use what you can see here. It's kind of like a brass or a copper scrub pad, and you just dip it into it or bring it across, wipe it. And as you can see now, we have a very bright, shiny tip ready to accept solder again. Keeping your tip clean on your soldering iron is extremely, extremely important. If it starts to get beat up or dark or black, you need to get it a good retin on it, which means clean it completely, flow some solder, make sure it's on. When soldering wire, there's a few things that you need to consider. First, how is it getting used? Is it going down through a circuit board? Is it going to be two pieces of wire soldered together? And if it is two pieces of wire soldered together, how is that wire needing to be joined? Do you need to keep it in a straight line? Is it going to be, in a bundle where we're going to solder ends together because they're going back somewhere else? There's a few methods of making that connection. The easiest, if you can spare the room, would just be to bring them together and twist them. This makes soldering that wire very easy because the solder will flow directly between it. Even if you needed to be in line, you could still have that twisted wire and you can pull it flat after you solder it. So let's just go ahead and look at this way. So we're going to take these two pieces of wire, we're going to twist them together, and put them in our helping hands here. But this time, we're going to do it a little different. I'm going to go ahead and add a little bit of rosin. In this case, it's flux. This isn't rosin. To the wire. Okay. And I want to show you how the solder will flow this direction. So we're going to add some to our tip. If we just come down on top of it, you can see that solder went right into that joint. That's the beauty of flux. It made a nice solid connection extremely quick and without having to put heat on that wire for very long. Now some insulations, like the wire we soldered earlier, this is silicone. This can take 900 degrees, 800 degrees Celsius before it would break down. This is a PVC jacket and it would melt a lot quicker. So this is a good way to practice soldering inexpensively. Just get a small spool of 28, 26 gauge wire, strip it, and solder. And let's look at our import solder. Where did it get off to? As you can see, it tries to, as it cools, especially, that needs to go in the trash. As it cools, it didn't flow down into our wire as well, and it's gray. Let's come back to either one of our other solder joints here. And you can see how bright that is and how it's completely into the wire. So inexpensive solder is not your friend. All right. Once you're comfortable soldering on some wire, whatever thickness that you may want to practice on, now it's time to move on to a circuit board. So, like I was saying earlier, Atari 2600s are still inexpensive if you need to work on one or you have one laying around. So, as you can see, many of the components here are what we're going to call through-hole style. There is physically a hole in the board, and let's see, Get this edge under the microscope. So there's this big capacitor here. This is a big electrolytic capacitor. And you can see that the leg comes out of it and goes down into the board. And there was a hole drilled in that board at this trace, and it's plated so we can solder to it. So these are through hole style. So there's a few ways we can deal with these. So first thing we want to do, let's just go ahead and desolder this. I'll find it. There it is. So, you know, we could do a couple things with this. We can use our braid, or we can use a desoldering pump or a desoldering iron if we were going to do a lot of them. And there's several styles, but here's an inexpensive one that has always worked fairly well. It's essentially this type of pump with an iron built into it, and it just sucks it right up through the tip. I only pull that out and heat it up whenever I'm doing a lot of through-hole capacitors on an old board. But matter of fact, we'll do both. We'll do both methods. So I'm going to bump up the heat a little bit on my iron. I'm going to bring it up to 420 Celsius because we're going to lose a lot of heat to this board. So you start with a clean spot of your braid, clip off anything old, and, excuse me for a moment. First thing you want to do is heat the board a little bit. And you can see that leg's already moving. And you can see that, matter of fact, you can see the layer of oxidation back here on the solder. But now that that's warm, we can come in with our braid and as you can see, it starts to wick away the solder. It's not the fastest, but if you have a lot, there we go. If you have a large mound of solder, which some of these old boards, these old boards were hand soldered. So, you could have a very large mound of solder that you need to pull away, and it's going to be more than a pump's going to take care of. But as you can see, this leg should be free now. There we go. And if we come to the other side, we should be able to lift it out of the board. There we go. So let's go ahead and look at the other side. And it's going to be this guy right here. And here's how to use a pump. A basic pump is just a plunger and a release. As you can see here, this one, the Teflon tip's all beat up because I use it quite often. And you don't need an expensive pump because these do wear out. I usually buy these 3 at a time because, well, they're just inexpensive. So what we're going to do is set our pump. We're going to heat the board. And on these old boards, it does take some time to heat. You can set it right on top and release. And for the most part, it'll pull the solder up. Like I was saying, on some of these boards that have a lot of solder, sometimes the pump isn't enough, but we'll hit it one more time. See, we'll get the rest. I don't think we will. So in this case, we can just grab the part, heat the leg, and pull it through. So there we go. That's removing a through-hole part. And here again, this is why you get a beater board, because now you can just sit and practice with wick on different components, pulling them out. And you don't have to worry about ruining anything, because if it was already a dead item, we're fine. So let's look at soldering a through-hole part. Now, on an electrolytic capacitor, they do have polarity, and you can see here there's a negative marking on it. So it's pointing at the negative leg. So all we're going to do, this is flared a little bit, so let's clean it up so we can get it into the board. So all you do is put the legs through and flip it over. Now in this case, our legs are pretty short. If they were full-length legs, you can just bend it a bit and it will hold us in place. So there's our leg. We'll clean our tip off. And this is very much just like soldering the wire. You're just going to come in. Always start with just a little bit on the tip. It helps heat transfer. Touch our pad, bring the tip up to the leg, add the solder, and let the solder flow. And you can see a nice bright joint. And we'll do the other side. And if we did it right, let's see, where are we at? If we did it right, the solder will actually flow through the hole and up the leg on the other side. Now, if you want this to look a little nicer, there's a few ways of cleaning. I always use alcohol and Q-tips. And you should always clean up your flux after. And there we go. A nice bright solder joint. Oh, one word on flux. We talked about standard flux for electrical, and we talked about rosin. There's also an acid core flux that is absolutely 100% not meant for electronics. It was meant for doing chassis work or plumbing, where you're doing large copper pipes and you need to really etch into them. It's not good. Stay away from acid core solders for electrical work. Even though this is supposed to just be a basic introduction on soldering and soldering techniques, because a lot of us still try to work on modern equipment, and honestly, surface mount isn't that modern. It's been around for quite a while now. It's just gotten extremely small in the last few years. You can get a small solder tutoring kit. This particular one came off Amazon. I think it was less than $8. I'll add the link below. And we'll open this one up together. And it came with some instructions. We'll look at those in a second. But the thing is, it comes with a circuit board that really has no purpose. And it comes with a bunch of parts. So we have different sizes here. And different, actually those are resistor arrays. So there they are there. This is, let's see, those are resistors. Those are capacitors. You can see them, they're gray. What do we got here? Those are also going to be capacitors. They're black, and since there's no numbers on them, I'm going to assume that those are going to be, although they very well could be resistors. We'll check one. What do we got here? Oh, we got little surface mount diodes. We've got, some small surface mount transistors. And of course, several types of surface mount ICs. Now, I don't know if these are good or if they're, rejects from a factory somewhere, but chances are whoever put this little kit together, they were just something inexpensive. A lot of times in industry, buying a small IC such as these, I'd have to look up the number to see exactly what it is. But, sometimes these can be, pennies if you're buying 1,000 at a time. It's really remarkable where electronics have gotten. And of course, we got a small circuit board with all of our pads. Now, there's several ways we can approach surface mount parts. One of the ways is to use a hot air gun such as this, where, and you've seen these in my other videos, where you heat the board, you flow the solder, and you more or less just set the chip right into the hot pad. And that works well on modern boards. We can also drag solder. I've never been real good at drag soldering, but there's ways of handling that. But boards like this are a great way to learn. Like I said, under $8, and it's not supposed to do anything when you're done. Now, if we look at it under the microscope, it looks like there are traces, like here. So here these are marked resistors, and you got a test point here and a test point here. So what I'm guessing, you could, for giggles, you could put a resistor here and then check it. And then you could put a resistor here and then check it. And that will show you that, when you have two resistors in parallel, since both of our tops are connected and both of our bottoms are connected, they're actually going to be half the value of the sum. So these are things you can think about. And then you can add and go and go and go and go. What's it look like over here on our, same thing here. These are resistors, but these are going in series. So this one's going into this one, and then into this one, and then into this one, and back and forth, back and forth, back and forth. And of course, you can see this trace here comes to this test point, and I'm guessing this test point is going to just come back up to here to our first pad. Yeah. So they've got some connections, but I'm, unsure if they're meant to do anything other than to check your soldering skills. We can take a peek at the instructions real quick and see what they have to say. Yeah, they don't say anything about the tests. So I'm guessing this board was made up for a class somewhere, and then they just picked it up. So we can take a peek at different ways of dealing with these parts. So why don't we come over to this edge of the board, to these capacitors, and we're going to get our capacitors. Now, these are very small, and even if you don't have vision issues, just using some readers of some sort is always beneficial. So, as you can see here, this is an 805 capacitor, 805 size. And you can see how small we're dealing with. This is, let's see, number 6. We're over down here. So we're going to solder it to this pad. So what I'm going to do is actually change. Now, I'll use this tip because it's a little bit bigger, and some of you may wind up with a bigger tip. So when you're hand soldering surface mounts, what I like to do, we're going to just move this one aside for a second. We are going to put flux down. Why? Because flux is our friend. Flux saves the world. As far as electronics go, flux saves the world. So we're going to start with a clean tip. And actually, I'm going to turn the heat back down a little bit to 400 even. Okay. So, we've got a clean tip. And I'm going to use the 6337 solder. I'm just going to get a little bit on my tip. You can see here, got a little bit of solder. And I'm just going to come in and touch this pad. Doop. And we get solder on it. And I'm going to clean the tip again. And I'm going to grab this capacitor. I'm going to do a little flux on it. And there's no way to do this without some nice sharp tweezers. And as you can see, the solder, since we have flux on everything, the solder just flows right up onto it. Now I'm going to try this as a lefty, if I have enough cord on my soldering iron, just so you can see it a little bit better on that angle. I'm going to put a little solder on our tip. I'm going to hold that capacitor down. All I'm going to do is come in and touch this. There we go. That's a soldered capacitor. Matter of fact, we could check it. Since we have these little test points, let's see where they're at. Okay, all these are in, they're all parallel. There we go. So we got 2 test points here. And there's our capacitor. And we can take a meter. Set it to, set it to capacitance. Now we don't know exactly what this is, the value on this capacitor, because nothing's marked, but we know it'll be soldered since it's not going to be open. So if we just hit the test points, it's 0.714 nanofarads. Let's just come down here and see if we get the same reading. Yep, pretty much. All right. So that's how we solder surface mount capacitors. Let's go ahead and look at one of these surface mount chips. Okay, as you can see on the diagram on the board, there is a notch here and a white dot. That always signifies our pin 1. So working on any of these boards, if we slide our chip over, we can see there's our dot. So this should go just like that. Now, like I was saying, there's a few ways we can deal with this. But what I like to do, if we're going to hand solder, we're going to use flux. Always use flux. Flux, flux, flux. Flux is our friend. It does a few things. Like I was saying, it helps flow that solder. And it kind of sticks our part into place. Just give her a little nudge. Give her a little nudge. There we go. Run all the pads. So, just like with that capacitor, we can get a couple of these legs soldered. So put a little bit on our tip. We're going to hold the chip down with some tweezers. We're going to solder that leg. Got a little too much solder, but we're okay. And we'll do the same thing on the other side, on the top corner. This time we don't need to really hold it. But if we come up here, you can see the solder flows. And that's the nice thing about the flux. So, drag soldering. Like I said, I'm not a real pro at drag soldering, but let's see how this works. Start with a clean tip. We're going to load the tip with solder. And ideally, you should be using a knife tip to do this. And you shouldn't be doing it left-handed for the camera. But let's see what happens. If we just come down. All right, you can see what's supposed to happen. As you drag down, the solder will flow from the tip and onto the legs. And we can do the same thing on the other side. And that all looks pretty good. They're all nice and bright. They're all shiny. Now, this is why we do some things under the microscope. You can see on this side, everything bridged real nice. You know, there's nothing bare. But this one little lonely leg down here, even though there's a little fillet on it, you want to give it a nudge, and it's soldered. It just didn't fill in the whole way. So, that's more or less how you're going to use an iron on surface mount. And I don't want to get too deep into the hot air station because it'll take us way too long. But if we need to remove a chip like this, there's two things we can do. We can either use a very low temp soldering alloy like this, but on something like that, it does make a mess, or we can use hot air. And for the sake of this video, I'm going to do the hot air. I'm going to show the hot air just real quick. And what it is essentially it's a soldering iron. It's controlled temperature. We can have this turned down to, since we're using leaded solder, we can have this turned down to about 420 degrees. And you can adjust the airflow and you can adjust the temperature. We'll let it heat up for a second. I've got some tweezers that I use for hot air work. And you just start heating the board. And it comes off pretty much that easy. And if we wanted to put it back on with the hot air, you can line it up, put a little pressure on it, and reflow the solder. And give it a second. And as you can see, that's on. And we're nice and straight. One last thing, I'll show you what's beautiful with the hot air. If we start heating up this capacitor and there's flux around it, it pulls itself right into position. Hot air is a newer soldering method. It works absolutely great. The downside is you can cook everything on the board. You have to take some time, work with it, but something like this would actually be nice. Or, and I'll try to link it below, a kit that actually does something when you're done with it. That way you know if you damaged any parts. But either way. So, there you have it. That's basic soldering techniques needed to work on all these video game systems. It's not easy. It's not something that you're going to grab the concept overnight. You definitely have to practice and do the methods I showed. Start with wire. Start with flowing solder properly into the wire where it looks like it's just coated wire opposed to a big blob. Work on soldering connections. Work on dead boards. Work on removing parts and resoldering parts. Buy a practice kit. And once you're comfortable with all of this, then you can move on to something you care about, like your Switch or your Xbox. But I hope you enjoyed the video. If you have any comments or ideas for future videos, go ahead and make some comments down below. And I'd appreciate a thumbs up. And I hope you decide to subscribe, and I'll catch you on the next video. Thanks.